Okay, so now I will be doing question 1. So the important concept, in question 1 is velocity and acceleration and how they are related. Okay, so the derivative of velocity is equal to acceleration. So I'm going to explain that more. So basically, acceleration is the rate of change of velocity with respect to time. So basically, the rate of change of velocity, so final velocity minus initial velocity over the change in time is equal to acceleration. So that means that the derivative velocity with respect to time is equal to the acceleration with respect to time. So that is going to be an important concept in our question. So basically, derivative velocity is acceleration, and that also means that the antiderivative of acceleration is going to be velocity. Okay, so that is the important concept here. Now I am going to read question 1. Okay, a plane starts at rest on a straight one-way. For the first 30 seconds, the plane's acceleration a is given as a function of time t by the equation a, or acceleration, is equal to beta times t squared. So I'm going to write that down. So in this question, it's saying acceleration is equal to beta times t squared, where beta is equal to 1 over 90, and t is in seconds, so t is time. What is the plane's speed at time equals 30 seconds? So to first do this question, as you can see, they give us the equation in acceleration. However, to do this problem, it's asking for the plane's speed. So we first need to take this acceleration. We need to basically integrate the acceleration equation, take the antiderivative to get velocity, and then integrate it to see what the plane's speed is at t equals 30 seconds. So what I'm going to do is so I'll draw a line right here. So I'll do velocity with respect to time is equal to the integral from 0 to 30 of acceleration with respect to time. Okay, so this shows the concept above, how the antiderivative of velocity, or the antiderivative of acceleration, is velocity. So that's what I explained in the concepts. Okay, so, and remember they gave us the acceleration, so I can say the velocity with respect to time is 1 over 90 t squared. Okay, and I just substituted that in. Okay, so for the next part, I'm going to integrate it. In order to integrate it, first I'm going to raise t to plus 1, so 2 plus 1, 3, so t to the third. And then I'm going to put that down over here, and I'm going to do the reciprocal of it. So it's going to be 1 to the third times 1 over 90. And so that will be 1 over 270 t to the third. And so that's the integral of 1 over 90 t squared. And you can prove that because if we take the derivative of this, so 3 minus 1 is 2, and then we take, put it down here, then we'll get 1 over 90 t squared. So we know that this is the integral. So it's the integral from 0 to 30. Okay, so now I'm going to integrate it. So I'm going to plug 0 and 30 into here and subtract. So I'm going to get 1 over 270 and then 30 third. Make a bracket here and then subtract it by 1 over 0 to the third. Okay, so this will be 0 because anything multiplied by 0 is 0, so we can just put 0 there. So it's only going to be here that we are worrying about. And 30 to the third, I did the math previously, it's 27,000. And then over 270, that is going to be 100. And because this divided by this is 100. And it's meters per second because we're finding its velocity, and that's the units for velocity. Okay, so the final answer to this question is C, 100 meters per second. In conclusion, this question showed important concepts of velocity and acceleration, how they're related. So the change in velocity with respect to time is equal to acceleration. And so we know that the derivative of velocity is acceleration, and the antiderivative of acceleration is velocity, and that's very important in solving this problem here. Okay, thank you.